All right, so today I thought I would address the simple proof, maybe not so simple, that the square root of 2 is irrational, the proving of it, so that nobody can question you. It's absolutely uncontroversial. And there's different ways to prove this. The most basic one is using proof by contradiction. So to suggest that this is irrational, remember what that means. It means it cannot be written as the ratio of two integers, okay? That's the definition of the irrational. A rational number is a number that can be written in the form of an integer divided by an integer. So a and b must be integers here, okay? So what we do is we assume that it is. I'm just going to say int for integer. So what we do is we say, well, root 2 is irrational. We want to prove that it's irrational. So let's make the assumption that it is rational, and then maybe along the way we'll come up with a contradiction. So that's how that goes. Okay, well then, if that's true, then I could square both sides. So what I'm going to do is I'm going to proceed to do some basic math that all of you should understand, and see if those basic math steps cause an issue. Well, root 2 times root 2 is root 4, which is 2. So that just becomes 2. And if I square the fraction, that means the numerator is squared, and so is the denominator. So that's where I get 2 there. So in other words, if the original equation is true, it's implied that this is true too. It's a deduction. Well, I can also cross multiply, or I could multiply through by the lowest common denominator. Okay, so I'm going to put that over 1, and I'm going to multiply across. So 2 times b squared is 2b squared. And 1 times a squared is a squared. So that's where we are there. Now I'm going to come back to my original two integers, and I'm going to make the assumption that they are relatively prime. Now what I mean by that is, if you take any fraction, let's say it's, I don't know, 8 over 12. Then that number could be reduced further. Do you see? Both of those numbers are divisible by 4. So I'm going to divide by 4, I'm going to divide by 4, and that leaves 2 over 3. So what I'm going to assume is that my a over b is the reduced form. In other words, I've already canceled away any common factor. And that means that a and b are relatively prime. Now this is 2 times b equals a times a. Well, look at this has a 2 on the left-hand side, meaning that this side here has to be even. Remember, one of the properties of an even number is that it's divisible by 2. So if a times a is equal to 2 times b, that means a times a has to have a 2 in it. It just does. That means one of the a's has to have a 2 in it. So therefore, well, not just one. If one does, they both do, right? So what that means is that a is even. Okay, that's our first sort of deduction. A must be even. If there's a 2 on this side, then a has to be even. All right, well, let's think about that further. If a is even, that means a can be written as 2 times some other number. I'm just going to call it c, a number that isn't used. Okay, so if we're deducing that a is even, then a is equal to 2 times some other number. Okay, well if that's true, then I'm going to take the 2c and I'm going to substitute it in where the a is. So that's going to tell me that 2 times b is equivalent to, well, a times a, which is 2c, times 2c. Well, look at this. If I do a little cancellation, I know that that 2 is going to cancel with this 2. As well, look, one of the 2's is still there. So that tells us something about b, right? Now I've got, once the 2 cancels, I've got b times b is equal to 2 times c times c. Well, we're right back where we were over here. If b times b is equivalent to 2 times c, b has to be even. Do you see? Because there's a 2 here. And having a 2 inside factor-wise means that this is even, so this is even if that's equal. So this implies that B is even. Well, think about it. If A is even and B is even, that's a contradiction to our assumption that A and B have no common factor. In other words, they're relatively prime. So, since we deduced by following this logic that A is even and B is even, it contradicts the original assumption that A over B are 2 integers that are relatively prime. And if these deductions contradict the original assumption that root 2 is a rational number, has been contradicted. So therefore, we can say root 2 is irrational.